time to get our hands dirty. So to start this tutorial, I'd like you to open the notebook that we have prepared. You can find it in the BigBrain forum. The list is also, the link was also just posted by PJ. And if you click on this link, you should see, sorry. All right, you should see something like this showing up. So I'll leave you a few seconds to get ready. At any time, if you have any issue, you can either post questions in the chat, or you can also use that shared Google document that I'm posting here to enter your questions of whatever nature, can be technical questions or more conceptual ones. And we'll make sure that we keep an eye on that. All right, so this, just to say a few introduction words on the technical setup. So we are going to run this notebook in the Google Colab environment. We chose to run this environment so that you can run everything and do all the exercises without having to install anything on your local machine. If you want to, if you prefer to run things on your own computer, so that you can then customize as you want and, have more ownership of it, it's always possible. There are instructions throughout the notebooks on how to do that. We provide a Docker container that reproduces the environment, and there are also installation instructions linked, if you want to do it yourself. So in this notebook, we'll have two types of content. We have text and slides, and we also have executable content, which is identified by these cells here, which have a little arrow. So what I would like you to do while I introduce the topic is to click on the first cell. This is software installation. This is going to install our software dependencies in your environment. I mean, in your Google Drive environment. And so when you click on it, you should see something like this showing up. It will ask you to log in using your Google account. So you should also do that. And then it will take a few seconds to download all the dependencies and install them. At any time, if you want to know what's going on and which files are being created, you have this left panel here. If you click on the last button, you can see the files, like the directory structure of the files which are being installed. You don't really have to look at them, but just in case, this is where the files can be accessed. So click on this first cell now, because it will take maybe 1 or 2 minutes to install. Okay, let me now introduce the content of the tutorial. This tutorial will have two parts. In the next half an hour to 40 minutes, we'll have like a low-level hands-on introduction to DataLad and boutiques. Our goal will be to go through a typical workflow where you will find BigBrain data, download BigBrain data using DataLad, process BigBrain data, and then contribute back your derivatives to DataLad. So the main added value of DataLad is that it provides us with a uniform interface to download data regardless of where it's located. And the main motivation of boutiques will be to provide a uniform interface to pipelines and to allow these pipelines to be transparently installed in CBRAIN. The second part of our tutorial, so after the break, will be about CBRAIN. So CBRAIN is a web platform to run data processing at scale on HPC clusters. So, the first part will be more command line based, and the second part will be more web interface based. Unless there is any burning question, I'll move on with the first part of the tutorial, which is about DataLad and boutiques. So what are our goals for these first parts? We'll have 4 goals mainly. First, where can we find BigBrain data in DataLad? Second, how can we install and download BigBrain datasets using DataLad? Third, the processing part, reusing this data. And fourth, uploading derived data, so your processing results, to DataLad we will actually use the backend of the Open Science Framework. So you can find Maurice gave and Petur gave excellent introductions, but it's we're only going to cover like the main introduction functionalities of DataLad and boutiques. You can find way more information under these links. We will also use the Canadian Open Your Science platform, which wasn't really introduced due to lack of time, but that I will show later today. As I was saying before, we'll do everything in Google Colab. You can find here a Docker container image if you want to do it in your local environment. Okay, I'll assume that everybody now has run this first cell software installation successfully. You should see, output messages looking like this. The last one should be configured Git, and the button shouldn't be spinning anymore. It should be inactive. If you have any issue or question, feel free to ask them in the shared document or in the chat. Okay. All right. Okay, so our first goal in this tutorial will be to find BigBrain datasets in DataLad. For that, in the Canadian Open Your Science platform, we actually have developed a web portal where people can search for DataLad datasets, not all the DataLad datasets, but a curated list of DataLad datasets which are of general interest for neurosciences. This is the welcome page of our portal. You can access it by clicking on this link. And if you go in the data search page, and if you type BigBrain there, you'll see a list of BigBrain-related datasets, which are available in the CONP, in the Canadian Open Your Science platform, and therefore in DataLad. In this tutorial, we'll use the first BigBrain dataset. So you can click on it. For each dataset, you have download instructions, which involve DataLad commands. And these instructions are exactly what we're going to run now in the notebook. We won't go back to the CONP portal now that we were able to find datasets of interest. But ultimately, you will be able to upload your derivatives to this portal and have the ecosystem of BigBrain datasets grow and be findable through this portal. Okay, now that we have identified a dataset that we'd like to download, we'll go through the instructions that you could find specifically for each dataset in the CONP portal. To download a DataLad dataset, the first step there is to actually install the dataset. A DataLad dataset is a Git repository, as Maurice was explaining before. So this step is equivalent to a Git clone. So you first clone the dataset. So you can click on this arrow here on this cell to execute it in your environment. What you can notice is that the cloning is definitely not downloading all the data. There are several terabytes of data available in these datasets that would take easily a couple of hours, even when relying on Google's infrastructure. So here, actually, this clone is a very lightweight operation that just install pointers to the files. If we look at what we have cloned, so here I changed directory to the CONP dataset. We can see that there are a couple of projects. These are actually all the datasets that you could find through the CONP portal. In our case, we'll be interested by the CBRAIN dataset. So we will install specifically the BigBrain dataset. So we will install specifically the BigBrain dataset That's also a DataLad dataset, and we'll just run DataLad install to install it. So you can click on this arrow here. As I was saying before, if you're interested by any other dataset, feel free to install it. Maybe not just now, but in principle, this can be reproduced for any other dataset. If we look at what's in this dataset now by just listing the files, we can see that we have several files there of different types, which correspond to different flavors of the BigBrain datasets, different blocks of BigBrain in different formats, Mink or Nifty. Okay, someone is saying that they are lost in the chat. I realize that. So, maybe I can go once again through the tutorial from the previous parts. And if you have any specific question you would like to ask, feel free to do it. I assume that you were able to open the notebook successfully, and that you were able to install the software by clicking on the first arrow button here. If that's not the case, please mention it. And if anyone else is able to follow and can confirm that everything's working correctly, that would also be good feedback. Okay, thanks, Anastasia. Okay, so it seems to be working for some people. So and we tested that quite a bit in the past week. So I'm confident that it should work. In that case, I'll just go through it once again. Just so that you're to clarify things that may not be obvious. Okay, so this notebook walks you through essentially downloading BigBrain data stored in DataLad, processing BigBrain data, and then finally uploading your derivatives. Okay, this notebook has a set of executable cells that you can run by just clicking on these arrows. The first part of the tutorial, which I'm doing now, and Valérie will do some parts right after, are really command line based. So they are supposed to show you how the basic infrastructure works. What are the main command lines? If you want to integrate them in your scripts, in your environment. The second part will be more web-based. Natacha will give it. Okay, so the first thing that we did here, we just installed software dependencies. Absolutely, Xiao, you need to be logged in a Google account, not to open the notebook, but when you click, the first time you click on an executable cell, it will ask you to log in using your Google account. Okay, so this is just to install the dependencies. You don't really have to worry about it. In this first part, I've shown you the CONP, the Canadian Open Your Science portal, which is a web portal where you can find DataLad datasets, in particular related to the BigBrain. So from this portal, we identified a dataset that we'd like to install in our local environment, and that's what we are doing here. We run DataLad install to clone the global CONP dataset. We listed the projects, the datasets available in this umbrella dataset. We retrieved a few BigBrain datasets from there, and having identified these datasets, we installed the specific BigBrain dataset locally. This installation actually doesn't download the data itself. It just installs file pointers to the data. So it's a quick way to have a command line exploration of what's in the data. For instance, if I list this subdirectory of the BigBrain dataset, I can find Nifty and Mink blocks at 40 microns. which together make the BigBrain dataset. There's also reconstructed 3D volumes, which are available in the datasets and which are available at various resolutions and in various spaces. I've seen that Claude Lepage and Lindsay Lewis are online. If you have specific questions on what's in these files, you should direct them to them, because they are the ones who actually know about how these files were prepared. Okay, I'd assume that you are able to clone the BigBrain dataset and look a little bit at the files in it. The last steps is to actually download the files of interest. So you can see, this two-step process. First, we install file pointers. We can look around and see which files are of interest. For instance, here you can choose to work using Mink or using Nifty. We are going to download a single file just for the sake of the tutorial. And to download a file, the command to use is datalad get. In my case, I had downloaded the file already. So it tells me that get is not needed because the file is already available. In your case, it should trigger like a progress bar downloading the file. Once you've done that, just to prove that data was actually downloaded, this is just a few lines of Python. You don't really need to read through these lines, but it's a few lines just to show that the data is indeed there. So it's a quick interactive viewer of a subset of a block of the BigBrain, just to show that data was indeed downloaded. Okay, so this is in a nutshell how to download the data. I'm going to look at questions, and then I will hand it over to Valérie for the processing part. So is there documentation on how the pointers work somewhere? Yes, absolutely. So the DataLad handbook is an excellent place for that. Just to summarize, these pointers are actually symbolic links. So just similar to file aliases, you just have the file names, and when you run datalad get, it actually downloads the files and put the data behind these file names. It says download failed. Do you know why? I could see that a few times. It happens sometime, maybe due to concurrency. You can try exactly. Thanks for posting your screenshots. You can maybe try again. It would say download failed, but then it retries. My guess is that the server may be a little bit overloaded since you're all doing that at the same time. At the end, if you have this final message, get not needed, 1, okay, 1, that's fine. It means that the data is there, and you can run the viewer to make sure that data was indeed downloaded.